So let's look at some inequalities and how we're going to go about solving them. So the first inequality we have is 0. We have x minus 3 is greater than 0, less than 4. So I'm going to just plot that whole equation on the graph where we're going to, and that'll be in green here. And then what I'm going to do is, let's go over and solve the inequality right here. We're going to add 3 to both sides. Well, all 3 sides really here. So this will give us 3x 7, and that's a valid statement. We have a 3 over here and a 7. So when we graph that, we'll have this. And it's important to notice that whatever falls on this red line is gonna fit into the green line when the equation's done. So for instance, we could choose this 5 right here. Let's let x equal 5. And if we put that into our original equation, we're gonna see that we get a valid argument. We get 2 is greater than 0 but less than 4. For this next one, what we're going to do is we're going to subtract the 4 from both sides. So give us negative 7, 2x, and we subtract 4 from here, and that'll give us 4. And now what we're going to do is divide both sides by 2. So these are basically carried out just like all other algebraic problems. The only thing is you're dealing with 2 sides now. So this will give us negative 3.5 center equal to x over 2. And that'll be right here, and it's equal, less than or equal to. So, and then it goes to 2, but it's not equal to 2. And in interval notation, we write this with a bracket and then a parenthesis. And up here, this one would have been 0 and 4. This next one, we're going to add 2, or subtract 2, my bad, to both sides. When we do that, we get negative 3, negative x, and then 7. And then we're going to divide by negative 1. So this right here should look wrong to you because we're saying that x is greater than 3, but it's less than negative 7, which wouldn't make sense. So we can't do it. And the reason is because our argument is wrong. We've done something wrong. We've had an error in our calculation somewhere. And the reason that we're getting this error is because when we divide by a negative or we multiply by a negative, we have to switch the orientation of the inequality signs. So back here, so this is not good. So when we divided by a negative 1 over here, what we had to do is swap the signs. So we should have swapped the signs like so. That would be our final answer, because that is valid. We can have a number that is less than 3 but greater than negative 7. I'm going to write this one in purple on this graph. That would be like this. Okay. In interval notation, we're going to notate this. -7 to 3, and 3 gets a bracket because it's equal to 3. Okay, down here, what we're going to do, we could do this by parts. If we did this by parts, first we'd multiply each side by 3. So this would be -3 times 3. When we do this, these 3's will cancel. We'll get -9. Don't forget our 5 here. 3. Then we're going to divide both sides by -5. But remember, when we're dividing by a negative or multiplying by a negative, we swap our signs around. So this will give us 9/5. So this is red. X is greater than -3/5, but X is less than 9/5. And in set builder, this would look like so. And graphically, this is not to scale, so it would look like, well, that's 3/5, so it's not -1. We're going to kind of draw it right here. And then 9/5 would be almost a 2. But remember, these are circles. They are not filled in because they are not equal to this, and then we would fill in the middle. The center right here. That's what it would look like graphically. So let's look at this next one. What we're going to do first is multiply by -4 to both sides. Remember, when we do this, we flip our inequality signs. These -4's cancel. We're gonna have 4 x plus 2 -4. Then what we're gonna do is subtract 2 from both sides, and that'll give us 2x -6. In interval notation, this looks like this. And on the number line, remember circles, it looks like that. And when you're doing these inequalities, always say the argument back to yourself. Does it make sense that a number could be greater than -6 and less than 2? And that totally does make sense. So over here, what we're going to do is divide. We see that they all three have an x that'll factor, so we're going to divide all three by a x. Now this is assumed to be a positive number, so we're not going to switch our inequalities around. That'll give us -1 x 1. And in interval notation, that'll be -1 bracket, -1 bracket, -1 comma 1 bracket. And on the number line, it looks like this. Okay, let's look at these ones. These are absolute values with inequalities. So for this one, what we're going to do is we're going to divide by 3 first. That'll give us an absolute value of x plus 2. The absolute value of x plus 2 is less than 1. So now remember, an absolute value is distance from 0, so it has two cases. We're going to have case 1 where the quantity x plus 2 is less than 1, and then we're going to have case 2 where x plus 2 is less than negative 1. And then we're going to solve. We're going to subtract both sides subtract both sides by 2. That'll give us x is less than negative 1. X is less than negative 1. X is less than negative 3. That'll be case 1 and case 2. I'm going to do case 2 in red, or case 1 in red, case 2 in purple. So we're going to have this one be case 2. This one be case 1. We would notate this one in interval notation as negative infinity, negative 1. And this one negative infinity, negative 3. Okay, I looked at the book, I cleaned that last one up. You probably won't be encountering anything to the crazy extent that I did have it in the beginning. So what we're going to do now is solve this final one, and what's going to happen is we're going to divide both sides by negative 3. Of course, when we do that, we switch to the orientation of our inequality symbol around, so this will be negative 1, absolute value of x plus 2. So now we're going to have case 1 where x plus 2 is greater than negative 1. And then we're going to have case 2 where x plus 2 is greater than 1. And to solve this, we're just going to subtract 2 from both sides. This will give us x is greater than negative 3. X is greater than negative 1. And this one would be, we're going to do this one in red, the other one in purple. The one in red will be that way, it'll be notated negative 3 to infinity. The other one is going to be in purple, and that will be notated negative 1 to infinity. And that's pretty much all with inequalities. So I think that wraps it up.